limitations of concrete. That means disadvantages of concrete. Okay, so every material will be having some positives and some negatives. So like that, this concrete is also having some limitations. The first one is low tensile strength. Okay, so as we have discussed in the previous slide, concrete is strong in compression. Okay, it can take compressive loads more compared to tensile loads. Suppose if this is your concrete is, as we have discussed, concrete is strong in compression. Suppose this is the compressive load nature, right? So this is how we are going to apply the compressive force. So when you apply the force like this, then it can bear maximum amount of load up to its limit. Okay, suppose say it has been bearing, resisting the load up to some x Newton per mm square, x Newton per mm square. Okay, so now, so say this x value is as 10 Newton per mm square. Okay, or else 10 kilonewton per mm square, like that. So this is compressive strength. Then here, if you apply tensile load like this, it cannot bear this much amount of loads. Okay, so the tensile strength will be somewhat less. That means the resistance to tensile loads will be less for concrete compared to other materials. Like if you take metal, okay, you can mold, you can apply the tensile loads on the metal, it can deform. But here, this particular concrete cannot deform like metals or else any ductile material. Okay, so the major point is here, it cannot take tensile loads as much as compressive load. Okay, it can take high compressive loads, but it cannot take tensile loads. Okay, so that you will get in clarity in the next coming lectures. Okay, so this is the first point. It is having low tensile strength. That is why this is one of the limitation compared to other material. Okay, the next one, low ductility. So ductility is nothing but here it is a nature of the material which can deform into a thin wire. Okay, when you apply a force on the material, okay, when you apply a tensile force, okay, here the nature of the load is tensile force. Okay, so whenever you apply these type of loads, tensile loads, this concrete cannot deform. Okay, it cannot change its shape like this. Suppose if you take any metal, okay, this is one of the metals, I am applying some tensile load by heating. Okay, by heating I am applying tensile load. What you can observe, this particular metal is going to elongate like this, it can change its shape. Suppose if you observe any one of the metals like gold, okay, or else silver, okay, as you are wearing gold chains or else rings, how it is molded into thin wires. Okay, if you observe the chain, okay, it will be like a thin wire, right? So how it is possible? What is the property there? Means this is what the property, the ductility property. That means that particular gold material or silver material is having ductile nature, ductile property. That means it is very very strong in ductile. When you apply a temperature on the metal and you pull it like this, you just apply tensile forces like this. Yeah, if you apply tensile forces like this, then it can bend or else it can deform like this, it can deform like a thin wire. Okay, so that is what the ductile property. Okay, so here if you observe the concrete material, can you pull it like this? Can you apply a tensile force on the member? Or else if you apply the tensile force also, it cannot elongate like this, like metal. Okay, it will break down completely. Okay, you may get cracks directly. Okay, so that is why it is having very very low ductile property. Okay, so that is what the second limitation. And next one, low strength to weight ratio. So compared to other materials, suppose I have manufactured one of the cube which is having 1 kg of, which is having 9 kgs of weight. Okay, just approximately assume it as a 9 kgs. And if you compare the strength of this particular 9 kg cube, then it will be around 23 Newton per mm square. Okay, just assume it as 23 Newton per mm square. Okay, so for 9 kg concrete, you are getting 23 Newton per mm square strength. But if you compare with the wooden material or else any other metal material, so the weight of the particular material may be less compared to this concrete, but it may give almost same strength. Okay, we cannot say it will give around 23 newton per mm square, but it will give same strength. Or else compared to the weight to strength ratio, it will be less. Okay, it will be more strength, it will give more strength. Suppose if it is a wooden member, okay, if you compare this weight ratio to strength ratio, then the strength will be more for less weight. But here for concrete it is not like that, it is going to have high amount of weight, and it is also going to give high strength. Okay, that is okay. Okay, here the weight is also more and the strength will be more. Okay, here the main point is the weight of the concrete material will be more for same strength, okay, compared to other materials. Okay, and next one, it is susceptible to cracking. It means when you apply the loads on the concrete member, so when you apply the loads on the concrete member, you are going to get the cracks in the concrete first. Okay, it cannot deform directly. If you observe any other metal material or else any other materials, so there first it is going to deform into different shape, but concrete is not like that directly, because this deformation will be observed if it is having a ductile property. Okay, if any material is having ductile property, then only we can observe this deformation. But in the concrete you cannot observe any deformation, it is going to fail suddenly or directly without getting any deformation. It is going to get cracked. Suppose if you take any ceramic material, okay, if you take any ceramic material, so what is going to happen if you apply the force on the member? Will it bend? It is not going to bend, right? So whatever the ceramic material is there, after applying the load, it can bear up to some point. But if you cross the limitation, if you cross the limit of the particular ceramic material, then directly you are going to get the crack. That ceramic stone or else ceramic material is not going to bend like this. Okay, so this property is called as brittle nature. Okay, whenever any particular material is breaking without without indicating, without any indication, or else without any warning. Okay, so here indication or warning is nothing but deformation. See here, this is initial material ma. Okay, I am applying the force. Okay, so after applying the force, if you keep on applying the force on the material, suppose if the material is bending like this. Okay, so this is the initial position and this is the final position. So after increasing the load like this, then it is going to bend like this. Okay, this bending will be occurred if it is having any ductile property only. Okay, that bending will be possible only if the material is having any ductile property. Suppose if this material is not having any ductile property, so what is going to happen means it is going to get cracks like this. Okay, it is going to get cracks like this without any deformation. See here, this is this much amount of deformation you got for ductile material, but here in the concrete or else any ceramic material, you are not going to get this deformation. This is the failure pattern. Directly you are going to get the crack in the concrete. So this material is called as brittle material. This material is called as brittle material. So for brittle material, examples are concrete and ceramics. Okay, so these are the two examples. We will be having a lot of brittle materials, but these are the two main materials as of now I am telling. Okay, these are the brittle materials. That means these two materials are not having any ductile property. Okay, very very low compared to other materials. Okay, it is negligible. Yeah. Okay, so now it is susceptible to cracking means when you apply the force on the member, directly it is going to get cracks easily. ఓకే, దట్ ఈస్ వాట్ హీస్ టెల్లింగ్. అంటే మనకు ఎగ్జాక్ట్గా లోడ్ అప్లై చేయగానే వెంటనే మనకు క్రాక్స్ ఫామ్ అయ్యే ఛాన్సెస్ ఎక్కువ ఉంటాయి. ఓకే, యా. సో దీస్ ఆర్ ద డిసడ్వాంటేజెస్ ఆఫ్ కాంక్రీట్ ఇన్ ద కన్స్ట్రక్షన్. ఎస్. Yeah, coming to the next topic here, cement. Okay, so all of you have heard about this material, right? So what do you mean by cement? How we can define this particular cement? So here, cement is a binding material. So cement is a binding material. Sorry. Yeah. So cement is a binding material. That means we can bind any other two materials by using this particular material. Okay, so it is a binding material which is having adhesive and cohesive property. Okay, this is very very important while defining the definition of cement. Okay, cement is a binding material which is having adhesive and cohesive property. So here, what do you mean by binding material here? Binding material is nothing but we can attach two materials. Okay, we can attach or else we can bind any other two materials by using this material. And after this particular point, here I have mentioned two terms, adhesive and cohesive property. So what do you mean by adhesive and cohesive property here? So can anyone answer this question? Molecular attraction. Yes, very good. Rule number 9, Sai Pranavia. Yeah, Sai Pranit. Yeah, very good. Sorry. Yeah, and any other student? You have already gone through these definitions in the previous classes, like in the previous subjects, chemistry. What do you mean by adhesive property? Sai Pranit's answer is correct, but still I need more clear answer. Molecular attraction between same molecules is cohesive. Very good. Yes. Next. Molecular attraction between different molecules is adhesive. Very good. Yes. Next, any other students? Nagesh and Pavani and any other students also. Roll number 30, 16, 14. Yeah, roll number 106, LE 106. Attraction between same materials is cohesive and attraction between different materials is adhesive. Very good. Yeah. Okay. So here coming to the definition of adhesive and cohesive. So if you look at different binding materials, like if you take a glue, any glue, okay, normal gum untundi kada. So if you take that glue, you cannot bind all materials with the glue. So what is the limitation over there? Why can't we bind with the why can't we bind all materials with the glue? Okay, so if you take any other material like any other what do you say, polymers, okay, epoxies, any other epoxies, okay, so we cannot bind all materials by using that particular glue. Or else if you take cement also, okay, so by cement you can bind any materials mostly, okay, 80 to 90% we can bind all the materials, but you cannot bind with the glue or else any other gum, because those particular binding materials will not have these adhesive property or else cohesive property. It may have cohesive property, some materials may have adhesive property. So what do you mean by adhesive? Means here, first of all, I'll discuss about the cohesive property. Cohesive property is nothing but, suppose when you take two molecules, okay, when you take two molecules, okay, so two cement molecules, okay, just if cement powder lonchi, just I'm taking two particles, two small particles only. So when you add water to the cement powder only, okay, I am not adding any other extra materials, I am taking only two particles from this particular cement, okay, these are the two particles, and I am adding some amount of water into these two particles. So what is going to happen here? Just tell me, just message in the chat box. What is going to happen after adding water into this particular two molecules or a cement powder, so what is going to happen? Bond takes place. Yes, very good. That means these two particles are going to be binded with each other, right? So that is what we are going to observe. Okay, this is very, very common thing which we are going to observe. So after adding water to these two cement particles, these two particles are going to bind with each other like this. Okay, so this particular property is called as cohesive property. Okay, this particular property is called as cohesive property. That means here what we are observing, attraction between the same type of molecules. Okay, here from cement bag I have taken only two samples or else some amount of sample. So if you observe, this particular cement particle will be same and this particular cement particles will be same. These two particles or two molecules will be having same properties, right? So that is why they are binding with each other when you add some water. Okay, so this particular property is nothing but cohesive property, attraction between the same attraction between the molecules which are having same properties. Okay, this is cohesive property. And coming to the adhesive property, so now adhesive is nothing but, see here, I am taking one of the examples of aggregates. Okay, in the concrete we are using aggregate, right? And these are the two aggregates. Okay, so now if you see, now this is one aggregate particle and this is another aggregate particle. So just a minute, I will draw like this. Okay, these are the two aggregate particles. So now I am adding water to these two aggregates. So what is going to happen? Again, just respond. What is going to happen here? This is one of the stone. Okay, in your language I will tell you, this is one of the stone and this is one of the stone. So by adding, I mean, to these two stones I am adding some amount of water. So what is going to happen here? Yes, ma'am. Can you answer? After adding water to these two particles, what is going to happen? Is there any development of bonding between these two stones? Yeah, good. Yeah, no bond takes place. Yes, very good. So here, when you add is a froze, no bond can develop. Yes, very good. Yeah, try to respond immediately, ma'am. Yes. So here, if you take two stones, normally this is very, very common sense. No? So these are the two stones, okay, which we are going to take, and I am adding water to these two stones. Okay, so it is not going to develop any particular bond between these stones because it is not having any cohesive property. Okay, so earlier we have discussed about the cement particles, right? So this cement is having same properties and this cement particle is having same properties. Likewise here, this stone is having same properties and this particular stone is also having same properties. But when you add water to these two stones, it is not going to develop any bond between these two. So why it is happening? Because it is not having any cohesive property. But in the cement particles, they are going to bind. Okay, that is what the difference between the binding material. Okay, so in the cement, so why we are calling cement as a cohesive material is nothing but because it is having cohesive property. It can bind with each other. Okay, but these aggregates are not having cohesive property. If you add any other binding material, only it can bind. Okay, yeah. So coming to the adhesive property, so now these are the two aggregates, two aggregate particles. Okay, and now I am adding cement also, cement powder also in this. So without mortar, they cannot bind with each other, right? So normally while mixing concrete material, you can already observe that. Okay, you may have been observed that. So first they will pour aggregates and then fine aggregate and then cement powder. Okay, so after that they will add water. So before adding water, if you mix these all materials, will they bind with each other? No, right? They cannot bind. So now if you add water to this particular all materials like aggregates and cement, Now what is going to happen? This cement powder particles are going to bind with this aggregate, the stones. So normally concrete మీకు ఆల్రెడీ తెలుసు కదా, ఆ కాంక్రీట్ ఎలా ఫామ్ అవుతుంది మనకు, ఆ అగ్రిగేట్స్ సిమెంట్ పేస్ట్ రెండు బైండ్ అవుతూనే మనకు ఒక హ్యూజ్ మాస్ అనేది ఫామ్ అవుతుంది. సో లైక్ దట్, డ్యూ టు ద సిమెంట్ పార్టికల్ ఓన్లీ ఇట్ ఈస్ గోయింగ్ టు బైండ్ విత్ అదర్ మెటీరియల్స్. That means what is going to happen? This cement particle property is different. Okay, this cement particle property is different, and this aggregate particle is different. But still, after adding water to these two materials, this cement is going to bind with this aggregate. Right? That means this property is different and this property is different. That means two different molecules. This is stone and this is cement particle, and the property of this molecule is different and the property of this molecule is different. It means still here it is getting attracted, it is getting binded. So here the definition of adhesive particles or else adhesive property is attraction between the two different molecules which are having two different properties. Okay, so this is different particle and this is different particle. Still there is an attraction between these two particles. So this attraction is called as adhesive property. Okay, earlier we have discussed about two cement particles. Okay, so attraction between the two similar particles is called as a cohesive property. And here this is one of the material aggregate and this is cement particle. So the attraction between these two particles is called as adhesive property. Okay, is it clear everyone? Difference between adhesive and cohesive property. I hope you got the clarity between adhesive property and cohesive property. Cohesive property is nothing but attraction between the same molecules which are having same properties, and adhesive property is nothing but attraction between the two different molecules which are having two dissimilar properties. Okay, yeah, that is what the definition of adhesive and cohesive. Is it clear? Coming to the cement definition, cement is nothing but binding material which is having cohesive and adhesive property. Okay, so now coming to the binding material. So why we are going to use, or else where we are going to use this particular binding material means for binding stones. Okay, to attach two stones or else number of stones, or else to bind sand. Okay, for mortar, for preparing the mortar, and next to attach bricks. Okay, for binding bricks or else any other building blocks. Okay, this is the application. Okay, for combining two, I mean for binding stones or else bricks or else any other building blocks. Okay, or else to prepare a mortar, cement mortar. Okay, for finishing purpose we are going to use a cement slurry, right? So sometimes we are going to use cement mortar also. So for preparing that sand mortar also we are going to use this binding material. Okay, so now coming to the principal material in the cement. Okay, so major material in the cement. Okay, cement will be manufactured by using different raw materials, right? So here the major material will be lime. Okay, it will be having compounds of lime. That is why the cement majorly it is called as calcareous cement sometimes. Okay, sometimes you will be listening the name of cement as a calcareous cement. Okay, don't confuse. So because of this particular compounds of lime, we are going to call it as a calcareous cement. Okay, it is also called as calcareous cements. That is because of the presence of compounds of lime as a major ingredient. Okay, out of 100%, this particular lime will be occupied around 60 to 70%. Okay, I will tell you the exact number in the next slide. Okay, in the coming lecture. Okay, so that is why it is called as calcareous cement. And next one, cements have the property of setting and hardening under water by virtue of chemical reaction. So that is why this particular cement is called as hydraulic cement. So whenever you add water to the cement, okay, so then only it is going to gain binding property. So before adding water, you cannot bind that cement powder with the other materials, right? So if you look into this powder, cement powder, can you bind with this without adding water? No, right? So when you add water only, it is going to gain that binding property. Okay, so that is why it is called as So when you add water to the cement powder, then only it is going to get that binding property or a setting of hardening. Okay, see below this particular cement powder, you have one block. So how it is become like a hard block? Okay, how it will become like a hard material? So that is after some time, right? So that is because of water only. So that is why it is called as hydraulic cement. Okay. Yeah. Yeah. Coming to the next part of the cement material. So here, normally whatever the cement we are using, that is called as Portland cement. So why we are calling it as a Portland cement means this particular material, cement powder, whatever the cement we are using, that is obtained from a place called as Portland. Okay, so it is a place. Normally Portland is a place. There we got one stone, huge stone, and after crushing that stone, they got a properties of cement. That means that particular stone is having the properties of binding. It is having some chemicals within it, and those chemical composition is making the cement powder to bind with the other materials. Okay, so that based upon the place we got this particular name. Okay, normally whatever the cement we are using, that cement is called as Portland cement, ordinary Portland cement. Okay, ordinary Portland cement. Okay, so the normal cement which we are using in the construction is called as ordinary Portland cement, OPC. In shortcut we are going to call it as OPC. Okay. Yeah. So now coming to the manufacturing, I mean raw materials of cement. Okay, what are the raw materials we are using for manufacturing of this particular cement means the first one is calcareous materials. Okay, so the first one is calcareous materials. Okay, this is the calcareous materials, which is one of the raw material. Okay, and examples for calcareous materials are limestone or chalk. Okay, you have already heard about this particular stones in the engineering geology subject, right? So in engineering geology, you have gone through the properties of limestone and sources of limestone and chalk. So that limestone will be used as a one of the raw materials in the manufacturing of concrete, and these two stones are called as calcareous materials. That means because this particular limestone will be having calcium as a major ingredient, or its lime as a major ingredient in it. That is why it is called as calcareous material. Okay, don't forget this. This is very, very important. Okay, one of the raw materials is calcareous materials, and examples for calcareous materials is limestone and chalk. Okay, and next one, the second raw material is argillaceous material. Okay, this is the major composition. Huh? Okay, first one is calcareous material, and second one is argillaceous materials. So argillaceous materials are nothing but these particular materials will be having silica as a major material. Okay, so before going through the examples, we need to know about what is calcareous material and what is argillaceous material. Calcareous material is nothing but it will be having calcium or else lime as a major material, major composition. The major composition in the materials is calcium. That is why we are calling it as a calcareous materials. And coming to the second one, argillaceous materials means these particular materials will be having silica as a major ingredient. The major portion of these particular materials will be occupied by the silica content. That is why these are called as argillaceous materials. Okay, the examples for argillaceous materials are clay and shale. So you will be observing normal clay, right, in the outside of the earth. I mean, sorry, on the surface of the earth. Okay, so that clay is a argillaceous material, and shale. Okay, you already know about the shale stone. Okay, so shale is also one of the argillaceous materials. So by combining these two materials, we are going to produce Portland cement. Okay, these are the major materials. Okay, along with these materials we may add some other materials also, but the percentage of those materials will be very, very less. Almost 80% will be occupied by these particular materials only. Okay, while manufacturing of cement, almost 80%. Okay, not exactly, but approximately 80% will be occupied by these two materials only, that is calcareous materials and argillaceous materials. Okay, by combining these two materials, by grinding these two materials, we are going to get Portland cement. Okay, yeah. Now here you can see the limestone. Okay, limestone and chalk. Okay, this is the chalk here, and this is the limestone. So these particular stones are called as calcareous materials. Okay, these are having high amount of calcium. Okay, this is the example for calcareous materials. And next one, this is shale. Example for argillaceous material. This is the stone shale. Okay, you have already seen this particular stones in the engineering geology lab, right? Yeah. Okay, this is the stone which is called as a shale. Okay, by using this particular stone and this particular stone. Okay, by grinding these two materials. Okay, we are going to grind these two materials and we are going to produce cement, Portland cement. Okay, yeah. And coming to the raw materials again, so how we are going to manufacture means by taking calcareous materials, that is limestone or chalk or marl and marine shell. Okay, these all are examples for calcareous materials. Okay, if you observe the examples for calcareous materials, this is one of the example of limestone. Okay, and next chalk, and next marl and marine shell. Okay, these are the four examples for some of the examples for calcareous materials. And coming to the examples of argillaceous materials, that means the materials which are having high amount of silica or else silica as a major composition. Okay, the first one is silica clay. Okay, normal clay, black soil or else red soil. Okay, and next shale, shale stone, and next slate. Okay, slate stone, slate mineral. And next one, blast furnace slag. Okay, slag is nothing but it is one of the waste material which is obtained during the manufacturing of metal. Okay, while processing metals. Okay, while processing metals, you will be getting some waste material. Okay, that waste material is called as slag, and that will be used in the manufacturing of cement as an argillaceous material. Okay. Yes, and coming to the temperature, okay. So while manufacturing the cement, so what is the temperature we are going to maintain? Means 1400 to 1500 degrees Celsius. Okay, 1400 to 1600 degrees Celsius. Okay, this is the average temperature of cement manufacturing. Okay, this is very, very important. Okay, you just have to note on this point. Okay. Yeah, the temperature of this particular cement manufacturing is 1450 degrees Celsius. Okay, we are going to burn these materials. Okay, around 1400 to 1600 degrees Celsius. Okay, this is the range of temperature. Okay, so after taking these raw materials like calcareous materials and argillaceous materials, okay, so these two materials are grounded into fine powder, and then we are going to apply some temperature, and at the temperature we are going to burn these materials, and you will be getting some powder like material that is called as cement. So now at what temperature we are going to burn those raw materials means this is the temperature 1450 degrees Celsius to 16 degree 100 Celsius, 1600 degrees Celsius. Okay, this is one of the important questions which may be asked in the competitive examinations. Okay, while writing government exams or else any other exams like GATE. Okay, so there you may get this question. Okay, yeah. So now cement is manufactured by using two processes, not two methods. The first one is dry process, and the second one is wet process. That means here the process is same. Okay, the grinding and the mixing of raw materials. Okay, and the composition. We are going to manufacture cement in two methods. The first one is dry process, and the next one is wet process. So what is the difference means here? In the wet process, we will be adding 35 to 50% of moisture content. That means water. Okay, we are adding 35 to 50% of water while manufacturing, while grinding those raw materials. But here in the dry process, we are not going to add this much amount of water. The water content may be very, very less, or else we are not going to add any amount of water in the dry process. Okay, so that is what the major difference between the dry process and wet process. Okay, you will be getting clarity while going through the flow chart of manufacturing process. Okay, so here from this point I want to convey that the cement will be manufactured in two methods. The first one is dry process and the second one is wet process. So the major difference between these two methods is the water content. In wet process, you will be having 35 to 50 percentage of water. And in the in the first method, that is dry process, we are not going to add any amount of water. Okay, this is very, very important. You may think that this is the question is very small, or else this topic is very, very small. You may think that just water percentage only, right? But this question will be raised in the competitive examinations. This may be for 1 mark question and 2 marks question. You may think that it is very, very easy question, but at the time of exam, you cannot remember these points. Whatever I am teaching now, from every slide, from every line, you will be getting one question, or else you are going to read that question in the competitive exam question bank. Okay, every point, every point. Okay, you have to note on this. Okay, and coming to the third process, semi-dry process. Semi-dry process is nothing but here we are going to add 10 to 14% of moisture content while mixing of raw materials. Okay, in the first process we are not going to add water. Okay, here we are not going to add water, that is 0% of water content. Okay, and in the second process, that is wet process, 35 to 50% of water, and third process is semi-dry process. In this particular process we are adding 10 to 14% of water content. Okay, mostly we are not going to focus this third method. Mainly we are going to focus on these two methods, but still if you get anywhere this question, then you can answer this. Okay, so these are the three methods for manufacturing of cement. First one is dry process, wet process, and semi-dry process. Okay, yeah. So with this I will end this session. So if